So I'm right here. I have a 10-minute talk, but I'm going to take like the first 30 seconds just to thank. I don't know if anybody can see what's going on in this room right now, but there is a lot of people in this room, and there's a lot of technology, and it's pretty awesome. And so kudos to the Data on Kubernetes like whole team and the whole community, because I love y'all, because it's the mixture of the two things I love most, data and Kubernetes. So today, I'm going to talk about delivering a serverless service on Kubernetes, right? And so I'm going to start. That's me. I'm a principal product evangelist at Cockroach Labs. I am not a database expert. I work with a whole lot of database experts. I'm super curious about this stuff. And honestly, I think this is the stuff that makes careers. So I like talking about this stuff. I think it's pretty cool. So let's just talk about the term serverless. For me to describe things, I like to go into the past, right? So let's take the word wireless, right? Wireless came about over the past, 30, 40 years. I had one of these phones when I was growing up. You dialed somebody, and if anybody had zeros in their phone number, you hated them because it took forever and you always messed it up. I'm aging myself, but eventually we had these wireless phones inside our house. We had mobile phones. And eventually we got to the point today where I've got this phone in my pocket, which is basically not even a phone anymore, I think. I don't even talk on it much. But we applied wireless to something, and that thing is still the thing, right? We've done this to cars as well. My first car is over on the, I guess the left, I don't know why I'm looking at this, but is the first picture on that screen, right? I could understand everything that was in that car. My current car is in the middle, my future car is on the right. The car is still a car, we've made it electric, right? And I think the same thing applies to what we're doing with data and what we're doing with our apps and services in modern compute. I believe that the term serverless a couple years from now will just be like the term wireless or electric or one of these things. It's going to be a way in which we deploy things because it is ultimately the most efficient way to do these things. Now for us, I work at Cockroach Labs. We're applying this to a database, which actually is apropos for this community here, y'all, because data on Kubernetes to me is Cockroach DB, but that's a wholly other separate topic. We aren't going to talk about that today. We're going to use this as an example, though. So serverless as a compute paradigm is kind of interesting, right? I think of these kind of 8 principles when this comes down to it. And by the way, I'm wearing my reading glasses, so I can't see the best, but I'm going to do my best here. Number one, it's about little to no server management. Nobody wants to actually deal with servers. Does anybody really want to go in and manage, upgrade, do all these different things? It's about automated and elastic scale. It's about resilience, right? I love this community, Kubernetes, right? We think about scale, we think about resilience. We think about things being always on, having instant access to things. But these last couple get really, really interesting. I think this is where our apps and services can stand to be very, very serverless. The way I consume software today, I want to consume consumption-based. I don't want to pay for things that I don't use. I want to pay for the things just that I use. And serverless allows us to actually do that. And I think applying these things to all of our software will get us really, really far. I think a lot of companies don't like their compute spend these days. And so how do we as software vendors and software providers help us become very, very efficient in terms of how we're actually using compute? How do we make these things multi-tenant? How do we share resources across multiple different instances using the same sort of things, right? So we can become this kind of consumption-based thing. For us, we think a lot about surviving failures. If you think about things like etcd in this community, if you think about what it does, it's just always on, always there, right? It keeps the state of that Kubernetes cluster going all the time, right? How do you make sure that you can survive any failure and always be on? For us, we have to think about this in terms of geographic scale as well. Because if serverless is truly serverless, right, are we doing this in a single AZ or a single region or a single Kubernetes cluster? Or are we going to do this across multiples? Are we going to do this, federate across multiple different clusters? Are we going to go across multiple different regions, right? What does geographic scale mean in this world? And I think ultimately the whole term serverless is a misnomer. I think it's infrastructureless. I don't want to deal with load balancers. I don't want to deal with all this other chaos that sits behind all these things. And I think if we can abstract all those things away, we'll build better software that delivers on a whole lot of value for people. Now, there's a couple of different things out there that are serverless already, and this is not what I'm talking about. I'm not talking about like serverless compute where it's like, like Google Cloud Run and these other things. It's not serverless functions like Netlify and these other things, right? And it's not these kind of new app development platforms. It's not the platforms we use to deliver the kind of these serverless like development things. I'm going to talk about how do we actually take our software that we have today, break it down, and make it serverless. And I think this can apply to everything. We're going to talk about data. I'm going to use the database to actually show how we do this and how we thought about it at Cockroach Labs. So most databases really are defined by 3 layers, right? There's a language, which I'm an advocate of SQL, number 1. There's an execution layer, which is, how do I actually select star from, what happens underneath the covers here, right? And then ultimately, every application just stores stuff to disk. That's what we're doing here. My friend Dan Goodman once said that every application is nothing but an interface between a user and a database, which I think is one of these, it's actually a really, really beautiful statement. But in Cockroach DB, we do it a little bit differently. And this allows us to do some really interesting things on that lower end of the list. We talked about geographic scale, we talked about resilience and always on. For us, language is SQL. There's still storage at the bottom, right? But what we're doing is we're doing distributed execution. Think about like back in the Hadoop days, like the MapReduce kind of things. But we replicate data. We don't synchronize data between different nodes, right? We can actually synchronize data across, we don't synchronize, we can actually replicate data across multiple Kubernetes clusters. A Kubernetes cluster can be a failure domain in this world as well, right? So how do you actually take your app and think about these things in a different way? And how do you become serverless? Well, the trick to serverless is really about, there are things that are ephemeral and there are things that actually need to be there all the time. And if you could think about your application in these layers about how do you actually tease out those things that are ephemeral, that which actually needs to be kind of on and there all the time, you need to find that divide and figure out where it is that you can actually divorce your application and tease it out into 2 parts. Now, not every application is a single binary. We implement ourselves as a single binary because I think it simplifies all this whole process, right? If you think about it, a database is a single binary, right? I have Postgres, right? What if I was to take the execution part of Postgres and separate that out from all the bits it's actually doing the storage? So there's 2 instances of how we would make something serverless on this one slide. For us, it's really about how we replicate and distribute, and then the storage stuff down below is really where things are going to be static, right? We're going to actually hold on to those things. Now we're going to do all this in Kubernetes, okay? So it's apropos for this particular conversation. But I think it's up to each one of us to actually figure out what that divide is and where that point is in their application to make this change. Now, for us, we can implement a single logical database across multiple different instances. So in this case, what we depict here is here's an instance of Cockroach running 3 nodes of Cockroach, each of them running in their own pod. And what we have is a single logical database so that you can ask any one of these nodes for the data, and it's going to serve back the data to you. It's wire compatible with Postgres, so it just seems like you're working with Postgres. But underneath the covers, you have this kind of distributed database going on, right? And so this is kind of how the normal world looks for us today, or actually yesterday, or 3 months ago. I don't know. What was it? It was like 8 months ago. This is what we were. And we actually, we deploy Cockroach DB. Our managed service is using this. It's all run on Kubernetes. We have thousands of clusters running on Kubernetes. We have some pretty deep SRE experience doing these things. And this is what really allowed us to figure out how to tease these things out and manage it very, very efficiently. So what serverless does, right, it's decoupling the execution and the storage. So what we did is we took an instance of Cockroach DB, which is that same binary. And when we started up, we actually started up with just doing the storage and replication, or we started up with just the SQL execution stuff on top. It's a simple flag. And that's what we're actually doing. So the SQL stuff, right, the stuff that's actually allowing you to run queries is done up top, whereas the storage done is one single cluster. Now the storage cluster is on all the time, and that has basically multi-tenant data. What we do in Cockroach, the way that we store data, it's actually one big KV store, and we're actually able to kind of segment data off into different users. That's a deeper architectural kind of concern, but we're actually able to firewall off each of the users from the storage cluster, right? And so we can actually tie data that's for a particular tenant, right? And so that storage cluster is just on all the time. And up top, we have this ephemeral layer that can come and go. When queries come or queries go, it doesn't matter. We're going to have SQL pods in place to actually interact with the storage that sits underneath, right? So we've teased away the execution from the storage side of things. Now, how does this allow us to work, right? So we can have multi-tenants all working on a single cluster, right? Here we have 3 virtual clusters, right? We have tenant 1, tenant 2, tenant 3. Tenant 1, tenant 3, you have 3 SQL pods because they have a lot of queries going on. Tenant 2, maybe they're just testing. They just started up a serverless cluster. You could start a serverless cluster on CockroachDB right now. But they're all sitting on top of this storage layer. And all of their data is actually in a storage cluster that sits underneath, right? So we have these virtual clusters up top, but one kind of big instance of the storage cluster that's sitting underneath. Now, currently, I forgot how many nodes that's actually running, but it's huge, terabytes and terabytes of data running on that thing. And it's shared across all these different tenants that are running on CockroachDB serverless. So what we do is we also spread, that was kind of the logical model. This is kind of physically how we actually work this. What we're also doing is we're spinning up these SQL pods, right? And we're actually deploying them across different AZs. So if I lose an AZ, I still have 2 copies of these pods moving, right? And so I still have access to this thing. More importantly, the storage layer is actually distributed across different availability zones as well, right? Because when we write data to Cockroach, again, we don't synchronize it between the different nodes, right? What we do is we have distributed consensus. So if you're familiar with Raft, it's actually a pretty interesting algorithm, a distributed consensus algorithm. etcd uses that as well. Actually, a lot of the work that we've done in CockroachDB in our implementation has actually been of Raft has actually been contributed upstream to Raft in etcd. So what we're doing is we're writing data in triplicate. It's going across 3 different nodes down below, so that if I lose an entire AZ, I still have 2 of 3 copies. This is actually across multiple different AZs, and we're going to do this across multiple regions too. And we have SQL pods that are just running across these things. So when I spin up the next cluster, I just deploy that in some AZ. I spin up the third one. What you're seeing is we're actually deploying these things across AZs so we can get this resilient nature, right? Not only can we scale all this storage stuff, we're going to be able to scale these SQL pods based on the amount of transactions that are going on within that particular cluster. Now, if we're going to do that, we also kind of have to have some way of mapping users to their pods. And so we had to implement something called a proxy. It's just our SQL proxy that allows us to direct users to whichever tenants. And so it's just got to manifest, and it just knows which pod to actually go to, right? And so it's actually the physical address of the pod that we're actually mapping to. And we're using Kubernetes to do all of this. We use Kubernetes because it allows us to become really resilient. And it actually allows us to start things really fast as well. And so it doesn't sound right. Like, is it easy and fast to start a pod? I'll show you how we actually do that as well, right? I'm not sure. Is there a time check? I'm sorry. Okay, good. I don't know where I'm at. So, I'm on like an hour and a half of sleep, and this is off of playing and doing the speech. So, when you also are doing serverless, this concept of automating scale, elastic scale, scaling up, scaling down, but allowing the system or the application to actually maintain that, actually a pretty difficult problem to solve. And if you think about this, we have 2 different layers of scale. We have transactional scale, how many pods do I need for each particular user? And then we have this kind of this data scale. And the data scale just kind of goes out. It just gets bigger and bigger and bigger all the time as people keep writing data. We don't actually throw away anything. And so we actually have this huge thing. It's really at the transactional layer that this elastic scale thing gets really, really interesting, right? So how do we deal with spikes in traffic? And more importantly, can I spin things down to 0? Because remember, we were talking about this. We're like, we don't want to pay for things we aren't using, right? And so how can I take pods and scale them down to 0 so that I'm not being charged for that compute, right? And I could take that pod out of the cluster, right? And this is just a simple SQL pod. So what we built is an autoscaler. And what our autoscaler does is basically monitors the CPU load within each pod. And it's looking at basically the usage over time and then like peak usage as well. Because sometimes pods get used like you have this blowout usage on this thing and then it comes back down. But we're always looking at the average over 5 minutes. And so it was an arbitrary amount of time. But this is really truly not something that's about the database. This is simply about the pod usage. And so this is where, to me, yeah, I'm using a database here. It's a little bit self-serving, right? But when you think about serverless and you're doing this on Kubernetes, this is one of those things that you actually have this insight into that helps you start to think about how you would actually think about autoscaling. We published a SIGMOD paper on this. It actually goes into it at depth, into exactly how we did this. Our SRE team and our engineers kind of came together to actually sort this out. So we're happy to share that with you. Join our Slack channel. Lisa, team will engage, we'll get you all these papers and stuff. So there's some really deeper stuff in this. So what does Autoscale look like? Okay, so here's my cluster I was talking about before. And what I've added here is this chart, right? And this chart just basically says, here's my standard load for tenant 1, right? And what I also have in each of the AZs, I have these hot pods, right? I have these pods that are just sitting there. And they're basically instances of Cockroach that are sitting in pods, and they're not assigned to anybody, right? So this manifest just has 0 user on it, or it's like a temporary user. They just aren't assigned, right? And so at this steady state, we have this kind of, what I need is like, I need 3 pods because my application is on, I'm getting about, I don't know, 100, maybe 1,000 queries a minute, you know, and this is basically steady state for my application against this database. So what happens when I have this, oh wow, man, I had a lot of time. What happens when we have this increase in time? What we do is we basically take one of these hot pods and we simply just assign it to that tenant. And so what I've done is I can actually spin up a new instance, right? Because the pod is already running. We can spin up a new instance of the SQL execution layer in literally milliseconds and have that up and running so that we can accommodate this increased usage. Now, we can do this for peaks. We can do this for, you know, gradually over time. Maybe I'm elegantly, you know, accelerating to 5, 10, 15 SQL execution pods. And so the system, the autoscaler actually deals with this thing, right? And so we have these kind of, the hot pods is kind of the hot pockets. The hot pods is really what allows us to do these things. And I think that's the trick of what we really designed and we really thought was really, really powerful for us. Because ultimately, that load's going to come back to steady state again. I'm done with, you know, my Friday afternoon rush on my application, and I don't want to be charged for all this compute, this excess compute, so I'm going to bring that cluster back down into a normal length, into my normal time, so that I'm actually back to my normal consumption. But also, maybe Saturday morning, all traffic goes away. And so the autoscale is actually smart enough to spin all of that down so that that particular user who's using our serverless instance isn't getting charged for that, right? And so the autoscaler is smart enough to actually do this. Now, the last step in this is like, okay, great, it's dead, it's Saturday morning. All of a sudden at 11:15 in the morning, somebody comes back and asks a query of our database. How quickly can we get that instance back up and running? Because you don't want a whole lot of transactional latency in that first interaction, but it's kind of hard to actually mitigate that completely out of the conversation without actually being able to spin down to 0. So we can get these things up and running. I think it's about half a second for that dormant cluster to come back on. We're continuously trying to find ways to optimize that. This particular instance of Cockroach DB has been in production since October. And so we've actually come down a whole lot in spinning dormant clusters back up again, because here we are, we're back, it's Saturday morning, I've got like a couple of different transactions coming in. I need to actually surface that thing, right? And so this is some of the ways in which not just serverless changes the way that we think, right? I think it's, when we start to design applications today, in the old world, there was this big monolithic application that I used to build. I felt sorry for those teams that had millions and millions of lines of code. We do think about it in functions. We do think about it in services. How do you tease out, how do you find that line between ephemeral and everything that needs to be static, right? And so I think that's really the trick around doing these things, because ultimately, I feel that serverless gives developers and SREs and ops people exactly what they want. Let's focus on the things that we want to do. Let's start things instantly, right? This whole like being able to spin up something very, very quickly, this whole kind of using hot pods to do that. Let's eliminate operations completely from the whole thing. And that's just basically the nature of Cockroach DB again. But this whole kind of management of compute and everything, nobody's actually dealing with increasing, nobody's going into etcd and saying, hey, I need more pods for this particular application. The autoscale is actually doing that for you, right? And that's how we get to kind of this autoscale. And then ultimately another kind of, I work at a company called Cockroach. The reason for our name was this kind of resilient nature of what we do, but the scale out nature of what we do is kind of one of these special things about the way that we've architected our software. Because ultimately, if you can take all of this stuff and make it really easy, what you're going to allow people to do is just do what you want them to do with your application. In our case, it's build. Do I really want to think about a database? Ultimately to me, I think a database should simply be nothing other than a SQL API in the cloud. That's it. Like, why we talk about deploying databases on Kubernetes is to me, that's crazy. I think we should allow database services to be just completely abstracted out to DML that you actually use to manipulate things, and it's a REST API in the cloud somewhere, and you actually code against those things. That's what we're building to, because we don't want people to actually think about managing and operating and upgrading databases. And I think serverless can do that for a database. Serverless can do that for your applications as well. All right. All right. Well, thank you very much. I think I was, I don't know, it got to be around 10 minutes.